All right, so we're gonna get started with our last subset of our EMI standards. So remember, for EMI 402, it's read the question, right? Then you're going to highlight the terms in the answer choices. So highlight your key terms in answer choices. Return to passage. And then match. Those are the 4 steps you'll need to follow for this standard, EMI 402. So let's go through it. So question 11, which of the following assumptions about CIP was made by the scientists in study 3? CIP is only achieved when ambient temperature is below 0. Tire pressure does not equal CIP. Maximum possible is 240. CIP only affects stopping distance at 60 kilometers per hour. So now let's go figure out what they did in study 3. So I'm going to flip to study 3. CIP is the air pressure when the vehicle is driven. Affect the braking performance inflated to a CIP of 160 kilometers. Initial velocity. Wet and dry roads. Table 3 shows the results. So then I'm going to go to table 3. Okay, table 3. So the CIP was 100, 140, 170, 210, 240. Wet, dry, wet, dry, wet, dry. These are the stopping distance, and those are their trials. So let's figure out what they did. All right, CIP is only achieved in the ambient temperature. Did not mention that at all. We can cross that off. Tire pressure does not necessarily equal CIP while a vehicle is being driven. We don't know. The maximum possible value of CIP is 240 kPa. That's the maximum they tested, so we could try that. Only affects stopping distance at 60 kilometers an hour. So they said initial velocity, but that means that it changed. So that's your starting velocity. So they started the car and then sped up, so we can cross off D. Now let's figure this out. Let's read study 3 one more time. Cold inflation pressure is the air pressure in the tires before a vehicle is driven. Okay, so CIP is before driven. And that means that it's what it's like before you turn on the car and drive it. So let's see here. Tire pressure does not necessarily equal CIP while a vehicle is being driven. Those two things talk about the same thing. So this talks about, that's just what they tested in the chart, but this one actually talks about what they might think about the system. All right, 12, study 1, so I'm going to be looking at study 1, makes the assumption that compared to a vehicle traveling at a lower velocity, one traveling at a higher velocity will. So, will not be able to brake unless it slows down first, possesses a greater coefficient of kinetic friction, possesses a smaller coefficient of kinetic friction, possesses similar levels of brake responsiveness. So, each with a different mass was tested at various velocities and values of UK. So, one traveling at a higher velocity. Let's look at our high velocity ones. So we're looking here, here, here. Okay, they have all the same UKs, and that's coefficient of friction, so we can probably cross off the friction ones as an answer choice. But then look, the stopping distance here is a lot bigger than in those ones. So our higher velocity ones take longer to stop. So let's see. It didn't mention slowing down first, and we know we can cross off the friction ones because we had only 0.3 and 0.6 for each value. So if you look at the table, right? Table 1 shows constant friction. Okay, so then our answer is D. So what we want to know then, because it does measure the stopping distance, right? We need that to have a control. So this is asking us for a control in an experiment. So we're assuming that we have that as the control. All right, 13. Which of the following was not an assumption made by the scientists conducting these studies? So because it didn't tell us where to go, that means I'm going to look right here. Stopping distance is the distance a car travels when brakes are applied to the vehicle, comes to a complete stop. So, how long it takes you when you start the brake to stop the car. Several factors influence this, including the velocity, the coefficient of friction, and mass. Okay, there we go. So, stopping distance is influenced by the skill of the driver. It does not say that in the passage, but let's not write it off yet. Oh, perfect. Okay, this says was not an assumption, so we want something that wasn't in the passage. So was this in the passage? Does it talk about driver skill? So skill was not mentioned. So we are going to leave that as a choice. Okay, friction is influenced by the physical properties of two interacting surfaces. So, did we study interacting surfaces? Yeah, we did. We road condition. So we did study that. Yep. In experiment. So we can cross it off. Stopping distance is influenced by multiple factors. We already know that because it says in the passage. So for this answer, for number 13, if it says in the passage or table, it's not the answer. So we want the odd one out. Okay, and friction between the tire and road surface is always present. So let's see, is there always friction? Friction, friction, friction. It's in everything, so, yep. So that means our answer is A. So, skill of the driver is never ever mentioned, and so that's our not answer. These ones are always the hardest because it's harder to find something that's not there than something that is. All right, last two questions. 14, which of the following assumptions about the vehicle's tires is critical to all three studies? So all three of the studies, if it says, if it doesn't point out a specific study, that means you go to the blurb, right? Okay, the tires may lose contact with the road surface during braking. The tires will remain in contact with the road surface during braking. The temperature on the vehicle's engine increases over time. The pressure in the tires decreases over time. So for all three studies. Now, I'm going to go ahead and cross this off because we never talk about engine temperature. That's not a key term at all, so we can talk about that. Now, here's a strategy point. There are two answers here that are almost exactly the same. So I'm going to immediately cross off D, and I'm picking between these two. So, what's the assumption? Is it that the tires will jump off the road, or that the tires will stay on the road surface during braking? Now, for this one, what we're assuming here is because there's friction, and we go back to the passage, and it says, kinetic friction, which describes the strength of friction between the tires and the road. So in order for friction to be present, they have to be touching the road. So the answer to 14 is B. So remember, if two answers are almost identical, it's between those two. Pick those two. Always. There's been like 2 questions in the history of ever where this rule does not apply. All right, last question, number 15. Based on the passage, the results of study 2, so based on the passage, that means the blurb, the results of study 2 are only valid if. So, let's read, we should read the answer choices first. I almost didn't take my own advice. Road conditions are identical between wet and dry roads. The degree of wetness for each wet road is similar. The tires are worn down during the braking process. Vehicles skid and spin when braking on wet roads. We can immediately cross off C because all 3 of these answers talk about wetness. So a key term is wet roads. Okay? So if it doesn't talk about wet roads, it's not our answer. Now let's go here to passage 2. So we wanted to go, and now it says study 2, so we're still going to look here, but it says based on the passage for study 2. So 3 different types of tires tested on both wet and dry asphalt roads. So this one again is talking about whether or not An experiment is good. So road conditions are identical between wet and dry roads. So we know that doesn't make sense because one is wet and one is dry. Vehicles skid and spin when braking on wet roads. That doesn't really give us like an assumption. So the answer is B. And that also is experimental design. So, right, when you're designing an experiment, you need your control variables to be the same. So I need to have a control, which means same wetness in each trial. In each trial. And there you go.